Hey, what's up, Mafia? Welcome back to the Code Cartel, and in this video, we will be talking about dependency injection. This will be the part 2 of Dependency Injection Masterclass. Previously, in Masterclass 1, a lot of people really liked and enjoyed that video, and it was great adding. I hope it added some great value, and I hope that this video would be on that level, and I'll be able to add more value to you now. So for now, let's get started. So these were some of the topics that we previously explored, which is what is dependency injection. We looked at examples of with and without DI. We looked at automated DI versus manual DI. We looked at alternative of DI pattern, which is our service locator pattern. We looked at flaws that are inside of manual injection, for example, a lot of boilerplate code. And if we want to scope it to a particular thing, we have to use singleton. Why should you use singleton, and why is it hard to test? So these were the stuff that we looked at. We didn't explore singleton in general. We'll start back at singleton and why should we use it and why is it so hard to test. We'll look at examples and we start with that. Let's get started. Let's start to explore. So previously we used this example exactly to understand the manual dependency injection. And as you can see, we were creating this login view model and trying to inject it into this activity called login activity. Now, as you can see, we have private latent var login view model right here. Let me quickly actually zoom in. As you can see, this is the thing, right? And on create, we try to make, first of all, the retrofit instance. Then we create a remote data source, and then we create local data source, and we create the user repository, and that user repository goes inside of the login view model, and then the instance is initialized in the on create instance. Now we have to initialize all of these things in order to create an injection of login view model and actually use it inside of an activity. And that was the flow. And what if we wanted to do another kind of, another injection of login view model in another activity? We would have to do all of this thing again. And that is a big problem. So these were some of the problems that we encountered in manual injection. If you look at the flaws that manual injection has, there is a lot of boilerplate code. If you want to create a login view model instance again, then we'll have to create all of the dependencies again. Okay, all of these dependencies right here, need to be created again. And that is a big problem. Dependencies have to be declared in an order. Login view model requires login repo must be created first. Okay, you can see that the login repo must be created first before the login view model, because login view model actually requires it. Without that, we cannot create the login view model. So all of these dependencies need to be created in a particular order. If it is not created in that order, that is a problem. So again, that is a lot of hassle for a developer. Now, it is difficult to reuse objects. If you want to reuse the objects, then we would have to follow singleton pattern. Singleton pattern makes classes hard to test. Okay, now if you want to reuse objects, for example, if you want to make another login view model and maybe use the same instance of the login view model, we would have to make it singleton, and that makes testing even harder. Now, what do you mean by testing harder, and how do you even make a singleton? We will explore that. Let's start with that and let's try to understand. And if you do not understand what I'm talking about right here, if you haven't watched the masterclass 1 of dependency injection, you should go and watch it first, and this will give you a good idea. This will give you a good idea of what I'm actually talking about. So let's get started with the singleton. Now let's start exploring what is happening with this particular flaws of manual injection and how we can solve them, and try to actually get to the point where Dagger Hill, the dependency injection, the automatic dependency injection is. So we'll look at the problem statements and try to get there to Dagger Hill. Okay, let's try to look at the problem statement as of now. When we are using manual injection, it is that it is difficult to reuse objects. Okay, so the natural inclination of anyone who understands objects in general would say that in order to reuse objects, just make it singleton, right? The solution statement would be, if you wanted to reuse something like user repository across multiple features, you would have to make it follow the singleton pattern. The singleton pattern makes testing difficult because all the tests share the same singleton instance. Okay, so the solution that anyone who understands objects would instantly come up with singleton pattern, right? So we should use singleton pattern instead of using any other thing. Singleton pattern has flaws, which is that it is hard to test. But how is it hard to test? Right, we will explore that. Let's first understand what is singleton pattern in general, because if you do not understand what is singleton pattern, it wouldn't be that clear. The singleton pattern. The singleton pattern is a software design pattern that restricts a class to a single instance, ensuring only one object of its kind exists and providing a global point of access to it. Now, what do I mean by this? It means that when we make a class and we try to initialize it, that particular object, that instance of an object is globally present, right? That particular instance is present globally. Another instance is not created. We are always using that one particular instance throughout the app, and that is what we call singleton pattern. Now, there are certain testing problems with it. Let's try to explore those. So let's start with an example of user repository. In order to use the same instance of the class, we have to make it somehow singleton, and that was a big problem when we are using manual injection. So the idea that we arrived was that we will use singleton pattern, but singleton pattern has an issue that it is very difficult to test. So let's just look at the code and try to understand why is it so difficult to test, and we will be seeing the testing examples as well. Okay, so that will make it much more clear. Let's take an example of user repository here. Now this is a class user repository. We have a private constructor here, and we are making an instance from this side. This is a singleton pattern. Okay, this is how you create singleton pattern in Kotlin. Okay, now the class user repository has a private constructor, has a list of users. Okay, and then we have a companion object related to this particular class. This is a volatile annotation. This is the instance that we have created as null. Okay, then we have get instance. This function creates a user repository right here and returns it. Okay, we can look at the instance right here. This is the variable that we created right here, instance. Then we have synchronized this. Okay, instance is equal to user repository. We created the user repository instance and assigned instance variable to it. Okay, now the user repository has been assigned to this particular thing, right? When we use this function called get instance, if you do not understand what is going on right here, it's pretty simple. It's that we're just using a function called get instance to get the instance of user repository. And what is this volatile? Volatile is basically an annotation that just says that instead of updating it inside of some kind of memory, we directly update it wherever it is declared. You can study about volatile in your time. When it comes to synchronize, this is that only one thread accesses this particular variable at a time, not many or not more than one. This avoids any kind of race conditions, and that is why we have created this. And get instance, we are using this function instead of declaring like this inside of login view model, because this is now this constructor has been privated right here. As you can see, the constructor is now private. You cannot use this thing outside of this class, so you have to use some kind of function called get instance. So that is the way we create the singleton pattern. If you want to study more about it, you can study how singleton pattern is created in Kotlin. Okay, now let's look at another function. We have save user function. Okay, and then we have get all users. Okay, see, these are some of the functions that user repository has. Let's try to use it inside of a service. Okay, now what do we see here? First of all, we create a service class. Okay, then we have a create user function. Okay, then we create a user. I think so user is a data class. Okay, user, we assign name and email to it, and the user is created. The user repository get instance, we create a singleton instance of user repository. Then we call the function called save user, and this user is present. Now you can see that the get instance, this particular class is being initialized inside of user service, and we have no idea what user service actually requires. So this whole user service actually depends upon user repository's functionality. If the user repository changes, we have no clue why the user service stopped working. Okay, so this could be a big problem if we are making some kind of instance inside of a class and we have no idea how this class is affecting the user service. This would cause a big problem in the future. So this is one of the problems that we will see in when we are using singletons, that the dependencies are completely hidden. We have no clue what dependency a class might require. And if you want to change some kind of implementation, you would have to change the user service as well. So that breaks solid principles. So again, That is a problem. When we see the function get users, list of user repository dot get instance and get all users. Again, we have to see the same instance. In order to receive the same instance, we use get instance function, and it will always give us the one instance of the user repository object that we have. Okay. I hope this makes sense. We are hard coding the dependency of user repository dot get instance. Now let's look at let's look at another class called admin service. It has get a user count. Again, we are creating user repository dot get instance dot get all users dot size. We are getting all of the users from the size of all of the users that are present inside of our app maybe. Okay. Now let's try to test this. What will happen when we do testing? Okay. This is a test class. Okay. This is a test function. Okay. First we create a user service, right? Then we try to create the service.create user. Okay, we create the user, the data class gets initialized and it is fed into the user repository. Okay, assert equals to 1 user repository dot get instance dot get all users dot size. It is correct that there's only one user inside of all the users dot size, right? Makes sense. We created a user, right? And when we created the user, as you can see right here, we saved one user inside of the user repository, and inside of the save user, what we have here is that the users dot add user, the users list gets gets one user inside of it, right? And get all users will return the list of users itself. So we only have one user inside of this list, right? So what is the size of this list right now? 1, right? So if we assert equal to, we'll see that the size and this one result that we are giving, it matches, right? So this means the test actually passed. Okay, so this is a good thing that the test actually passed. But what happens when we do another test? Okay, we have other test user count, well, admin service. We are now testing admin service. Okay, now assert equals to 0 admin dot get user count. Initially, when the admin services gets initialized, we are seeing that we don't want any user at all. When we are using admin service, we haven't created any user service because each test is supposed to be in an isolated environment. It is not supposed to be in one particular environment. Okay, so we have not created any user service here. We have not initialized any user here. We have not given any user to the user list here. So in this particular test, in this particular environment, there shouldn't be any user at all. Okay, every test is an isolated environment on their own. Makes sense? So this is a isolated environment. This and this does not interact with each other. Okay, hopefully it makes sense. So since this is an isolated environment and we have not created or added any users here, we can expect that there will be no users here. So assert equals to 0. And when we say admin.get user count, okay, what will we see? We'll see that the user count is actually 1 because the instance remains the same. The instance here and here are the same. The user repository instance remains the same. Okay, so the user that we added here in an isolated environment shows up here. So this makes testing difficult to do. This test completely actually breaks. So that is a big problem. So this test completely breaks. Now that is a big problem. This test and these two tests are not actually in the isolated area. They're utilizing the same instance. So that is causing the problem. And these are not isolated. And that's why both of the tests are not considered good tests right now. And that is causing the big problem. That is one big problem of singleton. Okay, let's try to look at another example of singleton. This is another case of using user repository, and instead of using singleton pattern, we'll use dependency injection and try to see how it becomes testable. Okay, now what we have created right here is a simple interface. As you can see, a user repository interface. It save user and get all users. Okay, makes sense. And if you look at the user repository, this is a database user repository. Okay, it has, what does it have? It has a list of users, right? It has save user, very similar function, and get all users, similar function. Okay, let's try to look at the service. Now, instead of creating the instance inside of the service itself, instead of creating the repository inside of the service itself, we are actually injecting it via a constructor. As you can see, the constructor gets injected with the dependency called user repository, and this makes the class testable. And secondly, we know that this class, there are no hidden dependencies. We know this class is actually being manipulated by user repository. So if we change user repository, this class functionality might change. Okay, and it follows the solid principles. It is not initializing the class itself. It is using its own functions, and it's tied to one single responsibility. So that is the great thing about this particular constructor injection. Okay, so we have create user. Again, this is a data class user, and then we repository will save user, repository to get all users. So this is the service. Now again, admin service, we do constructor injection of user repository here. Repository dot get all users. Okay, this is constructor injection, makes testable, makes the service testable, and again, all the rules that make singleton a big problem are being solved right here. As you can see, this is the data class called user, one name and one email here. Okay, this is a mock repository. Now what is a mock repository? Now when we create a user repository interface right here, we know all of the functions that a user repository will use. Okay, right. Another important thing that you can see right here is that the functions that we're using inside of a user repository, we have no clue about these functions. If we want to mock it, if we want to create a testing mock class, a fake user repository, we cannot create it because we have no idea what it is using, right? We have to create a complete different class. But in case here, we created an interface. We already know what are the functions that user repository uses, right? So we just use those functions and completely mock it. Okay, now private val users, right? Save users, users.add users. No database operations in this test. As you can see, there are some database operations right here. It means the database, the room database has been interacted right here. But in case of mock, we are not actually using this database. So what happens is, let's just say if we are testing and we are using actually user repository instance, then we are actually manipulating the database. The local DB we have saved inside of a device, right? And that is a big problem. We don't want to manipulate a DB because of testing. Testing is the whole idea that it does not go into production. It does not affect the production, right? So if the production database is being manipulated when you are testing, that is a big problem. And that is the problem that we are solving with this mock repository. Okay, when we mock this, there are no database operations here, and we can completely use a separate class just to test the user repository functionalities. Okay, let's try to use this inside of a test. We have a mock repo. We create a service and provide a mock repo to this thing. Okay, then we do create user, and then we assert equal the same thing. Again, it is an isolated test and it works perfectly. Okay, let's get to another test. Test user count, mock repo, mock user repository, admin service mock repo, and then we assert equal 0 admin.get user count. Always predictable, and it is working correctly. So let's take a look at another one. Test user creation with Mockito. Mock repo, mock user repository, user service mock repo, create user. I think so. This is from Mockito. Mockito is a library that we use for mocking or testing. So that is the verify. Instead of assert equals, we are using verify in case of Mockito. So again, it is very using Mockito for advanced mocking. Okay, it is related to a particular library, and testing not related to dependency injection in general. But this is how you do testing in case we want to do dependency injection, and this is how the classes become testable. And this is how you make classes that we don't use singleton pattern here. So what we have right here is an interface again for testing purposes. Then we have a database user repository, and this time we are using a private constructor, and inside of that private constructor we have a database and we have an API service. Okay, this is again constructor injection. Okay, and we are using the interface user repository right here. As you can see, we have companion object, and we are creating the instance of user repository by get instance database is equal to database implementation, API service implementation. Then we have the database service right here. The instance gets inside of this instance variable and returned from the get instance function. And this is another function that is very unique to this instance. Reset instance. Synchronize this instance is equal to null. we're actually trying to destroy the instance of singleton. This is very unique. We are actually trying to make the instance itself null through a function. It is an interesting take on resetting singleton for testing. Okay, so we have save user function right here. Again, we have get all users right here, and then we have user service right here. The user service has user repository dot get instance. Again, this is a problem here because the dependency is actually hidden, but let's see what it will do. Okay, and then let's try to test. Okay, now what we do is database user repository dot reset instance. So what we do before creating anything, we always reset the instance of the user repository. Okay, then we create a mock. Okay, mock database, mock API, and then we create a mock repository. Now, what is the advantage of this mock database and mock API service is that we are not actually manipulating the actual database, and we are not actually using the actual API service. We are just mocking it. Okay, using the Mockito. I think so. This is using Mockito. Okay, and then we get the instance of the repository. Now, mock database dot insert any returns unit, mock API dot sync user any returns unit, repository dot save user John. This is the function that we're using in repository. Verify mock database dot insert any, verify mock API dot sync user. Then we clean after the test. Okay, so basically what happens is we are trying to verify that mock database has any instance or not, and mock API does have any instance or not, right? This is what Mockito does. Okay, we use verify to do that. And then we have user repository dot reset instance again, in case we are having another test right behind this. Okay, right after this. So we are always cleaning up the instance. We are always resetting the instance before the test and after the test. And what does this do is that it creates a particular isolated condition for this test even when we have singleton. Okay, and that is how you do testing with dependency injection and singleton pattern. It's a very weird kind of situation here because we have to write so much code and we have to remember so much, and that could cause a huge problem when we are creating such a large app. Imagine using eBay, this kind of pattern. That is very difficult to do, and it becomes very hard to think and see what is going on, right? For example, if a user forgets, what a developer forgets something like this, we have no clue why a certain thing is happening until unless he is aware of resetting the instance. Okay, now that is very hard to do, and it becomes this is how we do singleton with dependency injection. This is how we do singleton or testing, not with dependency injection. This is how we do singleton and testing. So these are some of the problems that a singleton is giving us. Now, test isolation. Tests cannot run independently because they all operate on the same singleton instance. If one test modifies the repository state, adding users, changing configs, it affects the subsequent test, leading to an unpredictable test result. The singleton pattern introduces a global state into an application, which makes test independent. Okay, which makes test dependent, not independent. Okay, so that's the thing about testing with singleton pattern. It's that it's difficult to test because we are using the same singleton instance, and it is becoming difficult to, if we manipulate anything into that instance, it carries through all of the tests, and that is causing a big problem. That's why when you're trying to test in singleton instance and trying to solve the problem, we created this reset instance to actually reset the instance again. Okay, inability to mock dependencies. Since tests must be actual singleton instance, they cannot substitute mock implementation for testing purposes. This means tests might perform actual database operations or network calls instead of isolated unit testing. The singleton global access makes it difficult to mock singleton because get instance method always returns the same real instance. Okay, now what is happening here? Then tests must use the actual singleton instance, they cannot substitute the mock. So what is happening is that the singleton instance of the user repository is actually manipulating the actual database. And if we are manipulating the actual database in cases of tests, and tests are not supposed to run on productions, that is a big problem. That's a big no-no for any condition. And that is what is happening. We are unable to mock the dependencies because we have no idea what are the functions that a user repository might be implementing, because we have not created an interface. And since we have no idea, we are actually using the instance, the single instance. I think because of singleton instance, we are actually manipulating the production level database in case of tests, and that is a big problem. And also, we are not performing any kind of isolated unit testing. That is again a big problem. I hope it makes sense. Now, hidden dependencies. Classes that access user repository.get instance have implicit dependencies that aren't visible in their constructors or method signatures. That makes it unclear what each depends on and what makes dependencies more complex. So this is the thing, that the dependency of user repository.get instance, in case of this thing, as you can see, when you're using user service and you're using singleton instance, user repository.get instance or save user, this whole thing is hidden inside of this class, and this class is not class is now responsible of creating this instance. It becomes hard to understand what this class might depend upon. If a new developer arrives, he has no clue what this particular service depends upon unless he goes through the whole code, and that is a big no-no. We want the class to be responsible for only one thing, that is called single responsibility. We don't want it to create an instance as well as do its own thing. So that is a big no-no. So this was some of the things that the singleton is causing problem. Hopefully it makes sense now. Let's try to explore even further and try to understand what is happening. Now, initial idea was to actually make the classes singleton in nature, but this whole rabbit hole of singleton got started when we wanted to actually reuse objects, right? The initial idea was to use singletons because singletons have the idea that the instance is present globally throughout the objects, throughout the app, and that becomes harder to test the classes. That is harder to test and mock the classes, and that is a big no-no. And there's a lot of problems with singleton overall. So we don't want to use that. So what is the other approach to use instead of using singleton? Another approach is using some kind of app container. And this is where we start to see the pattern, the move towards what we call dagger hilt. This is the starting point of dagger hilt. This is how the dagger hilt works under the hood. Okay, this is the starting point of an app container. Now, what is an app container and why do we use it and what is happening? Let's try to see that and let's try to understand it. Now, instead of using singletons, the idea was to actually shift to something called as an app container. And how can we solve and reuse the objects through an app container? And through that app container, we derive the idea of dagger hilt. Okay, we will get to this point afterwards. But for now, let's try to understand this app container idea. Okay, instead of making the classes singleton to promote the reuse objects, we can make an app container which would manage our dependencies. Okay, interesting. So it is kind of a container that is responsible for creating and managing all of our dependencies. Interesting approach. When we make an app container scope to the application, we can get the dependencies from the container. Makes sense that we have an application class. If you are an Android developer, you would understand there is an application class in Android that you can create, and we scope the app container to this application class. Then this app container is alive throughout the application, throughout the app, right? And we can get the dependencies whatever we want from this container again. Just makes sense, right? Let's try to create one. Okay, this is an app container. Okay, we create an app container here, right? Container of the object shared across the whole app. Since you want to expose user repository out of the container, you need to satisfy its dependencies as you did before. As you can see, we first created the retrofit, then we created the data source, the remote data source, the local data source, then we finally created the user repository. Now this user repository can be accessed from this app container class anywhere, and this app container will be inside of an application class, right? And that would solve our problem. Okay, Let's try to use it. Now we created an application class right here. As you can see, this is an application class, and we have made an app container instance here, a custom application class that needs to be specified in the Android manifest.xml file, and the instance of app container that will be used by all the activities of the app. Okay, this is how you create the app container and give it to the application class. Now let's try to actually get the user repository into the login activity itself. Now this is the login activity. We have the login view model that we want instance of. We get the app container right here. App container application as my application.app container, get from the my application class. We get the login view model, and the login view model instance require the user repository that comes from the app container right here. And as you can see, this instance will be singleton in nature because this particular class is present only in the application class. Sorry, this particular instance is this particular instance of login view model, this particular instance of user repository is being reused because it is present inside of an app container that is present inside of an application class right here. So the app container is present inside of an application class, right? And from that app container, we are getting the instance of user repository, and the user repository is present there, and this instance is present throughout the application. Okay, this one instance is present throughout the application. So we are actually reusing the objects of user repository, and that is the start of what we call dependency injection with app containers, and that's how we got to Tiger Hill. Okay, now let's try to see how we can create different instances of view model, right? What if we want different instances, not different instances, we want the instance of view model to be used throughout the application. How can we give view model to the app container itself? So what we do is we create a factory, right? A definition factory interface with a function to create objects of a type. Okay, this is just a generic factory, right? We implement the login view model factory. We give it a user repository. The factory just creates the login view model and returns to us. Very simple function, right? This is a very simple class called login view model factory, and this factory is responsible for creating the login view model. Let's try using it once. Okay, inside of our app container, we can see that what is happening. Inside of the app container, we can see that this is the app container. This is the user repository. This is the remote local data source that we created before, and all of the dependency like retrofit, remote and local database source requires. Then we create the user repository. Then we ask the login view model factory. Okay, I'm giving you the instance of user repository. Create an instance of login view model and give it to this particular variable right here. Okay, and inside of login activity, we have login view model private latent login view model. We get the application app container right here, right? And from the app container, we simply ask the login view model dot create function to return the login view model. Okay, and that is how we got the instance of login view model according to the app container, right? Makes sense. This is how we are reusing the objects like login view model, user repository with the help of an app container. Now if you're wondering why are we using a factory instead of just creating a login view model right here, right? A singleton instance of login view model inside of an app container and share it across the whole app. That is a big no-no, because the login view model is supposed to be tied to the login flow, right? It is not supposed to be tied to the whole application. I don't want login view model to survive everything outside of a login flow, because what would happen is that this would create some kind of memory leaks, and it is not tied to the life cycle of a particular activity, right? And that is a big no-no. We don't want that. So that's why we are creating a factory that only when we need it, we create it, right? That is how we create it. Okay, it makes sense. I hope it makes sense. I hope it makes it pretty much clear. And if you want to revise all of these things, the easiest thing that you can do is go to the manual injection or dependency injection documentation of Android. I picked up examples from that only. Okay, and you can read through the application itself, read through the documentation itself. And from this particular video, it will give you a very good understanding of what is going on. You don't have to read any more notes and require some documents or anything else. It's everything that you need inside of everything that you need to understand this particular video is inside of that documentation. Just go and read. It will give you a very good idea. Okay, it will be a very good revision. Hopefully you guys really enjoyed it, and this was a very good session for you, and I hope I added some real good value to you. And if I did, you know what to do. Like, share, and subscribe, and of course I'll catch you next time. Bye bye.